This one's kind of funny.
Yeah, just sirens, ambulance.
Every few minutes.
Yeah.
Okay.
Yeah,
So we
this
got a lot
one.
to do here.
Yeah, I kind of want to work on a few of these because I get confused on the wording on like what it's asking for and how to like test these like hypotheses.
Got it. Just trying to get where I can snip this. Could you make your window slightly like half screen, maybe?
Like
The
like this.
yeah, the Safari. Yes, that's much better. Okay. Yeah. Which questions do you want me to grab snips of?
Like maybe 16, 17, 18.
Sure.
Yeah.
Now, it's possible that I will need, we'll see here if I'll need any of the formulas, because okay, I got 16. If you're gonna go to the next one.
Mhm.
All right. 17. Got it.
Like 18. I think these are all pretty similar.
All right, got it.
And then I don't know if this one is different. Maybe like this one, and then we can like go from there
Okay.
so we can like learn the differences.
All
We
right.
can start with
Got
those.
it.
Yeah.
Any others in this batch, or does that
We could just
sufficient?
start with those.
Okay. All right, so let me snip these into my other screen here.
Mhm.
All right, I'll share my screen and we'll get started.
Do you need me to get like the formulas, or I have some of them
You
written
can
down?
if you can send over if you have a formula sheet, I always kind of prefer to refer to the student formula sheet than
Yeah.
my own. It's a little better than that way you guys
Let
can
me
see.
see like what we have. Mm, yeah, I can grab like one. The main one we're using is like the t equals x bar minus mu over
Yeah,
s
yeah,
divided by n squared.
right, right. So for this first one here, if you're seeing my screen here,
Yeah.
they are giving you the population standard deviation. So that's when we get down there, that'll be a z. But
Yeah.
the
Okay.
null and alternative hypothesis, um, you have to decide. Uh, Usually, it's easier to find the alternative first. There's some sort of a word in here, and in this case, it's reduction.
Mhm.
Uh, that means that. Oops, let me grab that again. That
Mhm.
word reduction means that you believe that the mean has gone down from whatever it was supposed to be.
Okay.
Okay, and and you're looking for that one that says like, hey, this is the value that we think it's always been, always
Mhm.
been forever and ever and ever.
Mhm.
Now, the null depends on the class. Okay, you're doing it correctly in the class. All right. So the null is the other direction.
Mhm.
So in your class, there are three pairs of things that go together. So this is the null, this is the alternative. So if it's mu equals some number, it's now mu not equal to, mu
Mhm.
greater than or equal to, mu less than or equal to, mu greater than. So these are the,
Like rules.
yeah.
Okay. Yeah. Okay, I have those written down.
If you can you check these just to make sure?
Yeah.
Um,
Um, yeah, I can do that. I have three submissions, but yeah, I will put those in and just make sure I have the right. It's loading. Okay, those were both incorrect. Mm, uh, did your microphone cut out? I can't hear anything.
I apologize. I'm happy to look at your screen, or if you want to look at the try another, but did you use mu or u? Mu
I
is the
used
Greek
the
letter.
U.
Got to use the mu, that Greek letter mu.
Yeah, where, let me find.
And I'm happy to help you find it if you want to
Yeah,
share your
here, I'll
screen
share my
again.
screen. Oh, here. Where is it not? You, it's not
I'm
showing.
not
Okay, here,
I'm
share.
not seeing your screen quite
Yeah,
yet.
yeah, I don't know here.
There's going to be on the right, it's going to say Greek letters.
Greek,
Okay, so the
yeah.
mu is the one down up right there. Up, you got it. Up two. There you go.
Yeah, I submitted both of these and that didn't work.
Oh no, no, you're in the wrong problem. So this is 16.
Right. Oh my gosh.
Oops. I've done that.
That,
Okay.
yep. No, there we go. So,
I would clear out those answers from the other one though, because it will try to resubmit them if it thinks that you're, yeah. And
yeah.
that was, yeah, less than.
Like so? Yeah.
Yes, let's try that.
Yeah, there we go.
Right, fantastic. Okay, so I'll go back to sharing my screen and we'll
Mhm.
continue working through these.
Mhm.
So as you mentioned, you're two types of distributions. One is a Z, one's a T.
Right.
Because the sigma is given, you're using a Z, which is X bar minus mu over sigma divided by the square root of n. In
Mhm.
your problem here, X bar is 2.23
Three. Mhm.
minus 2.30 over 0.19 divided by the square root of 36.
Six.
And it says to round to two decimal places. So grab your calculator if you've got one.
I'll do
And
it.
we're going to
2 decimal places.
so
So
I
zero
got
point.
minus
Oh,
2.21.
I got positive. I think I did
So 2.23's got to come first.
first.
That's the
Yeah. Here, I'm gonna read them to you.
okay. Now,
Yeah.
so you can always try these as you go. Probably a good idea. Um,
Yeah, I have 3 attempts on these, so it's kind of hard to submit like multiple times on each problem. Or wait, actually, I can do that. Two, one. Yeah, that was correct.
so now the p-value,
Mhm,
we want the area to the left of minus 2.21.
mhm. And that's where we go to like our uh, table,
Yeah.
and then I'll type that in for the z-score, and it'll give me the probability.
Yes.
Yeah, and then that's 0.01. I have to round it to 4, so 0.014.
I got you got three. You only got you went to three. 0.0136.
Oh, wait, 6, yes. 0.0136, yeah, got it.
Okay. So now the part D, if the p-value is less than the alpha, which it is in
Mhm,
this case, you
mhm,
reject. So it's either the second or the fourth. And reject always goes with there is sufficient.
mhm.
So there's your final
Answer,
answer.
got it. And the p-value was yeah, so it's less than 0. Wait, which one is
Here's the alpha right there.
the alpha? Got it. So it's less than, therefore we reject. Okay, got it. I gotcha.
Okay.
Mhm,
So that is it for that one.
mhm,
We'll go to 17.
mhm,
Wait, okay, I'm in the wrong place there. Okay, 17. So kind of the same idea here.
mhm,
Um, they tell you that sigma is known, but to do the null and alternative, you're looking for a word like decreases, increases,
mhm,
stays the same,
mhm.
within 16 days of purchase. So this one's a little bit unclear, but I believe it's this. the word within means they're saying, hey, it's gonna be 16 days.
16 days. Got it.
Yeah.
Okay. Oh yeah, I'll type that in really quick. Oh yeah, got that.
And Z is again, X bar minus mu over sigma divided by the square root of N.
Hmm.
So you might be wondering, well, how do I know which one is this, which one is the mean? It'll tell you that in the sample, the mean 16.9 minus 16,
Hmm.
5.6 divided by the square root of 49. So you're going
Hmm.
to calculate that value again.
Yeah. I got 16.49.
I think you got a parentheses imbalance on
Do
that.
I have to put the parentheses in the denominator or
Yes, yes.
okay, so here, let's try that again. So to divide it by, and then do I do parentheses 5.6 divided by
Yeah, you might
49?
even have another set of parentheses in there.
Oh, okay. I'll try that. 6 divided by 4. Negative 3.1. No.
It's pretty sure it's 1.3,
Okay, I'll try it one more time.
1.13.
Okay. So do I do parentheses 5.6 and then do I close it and then do divided
No,
by?
no, it's on the bottom. It's parentheses 5.6 slash square root, open parentheses 49, close.
Mhm.
And there's a 16.9 minus 16 in the top.
Minus 16. Okay, I'm still not getting it.
Do you want me to pull up my calculator?
Yeah, that'd be
Okay,
helpful.
all right. Just a moment here.
That's right.
If you're seeing my screen here, parentheses
Mhm,
16.9
mhm,
minus
mhm,
16,
mhm,
close parentheses slash
mhm,
parentheses 5.6
mhm.
divided by second square root
Mhm.
49, close parentheses for the square root, close parentheses for the denominator.
Oh, wait, now I got it. Okay, got it.
All right.
Yeah.
Okay. And now let's go back to our workspace here.
Mhm.
We're actually going to come down to C and we'll go back to B.
Okay.
This time it's a two-tailed test. So
Mhm,
it's 1.13 and then minus 1.13. You've
mhm,
got to find the area in both tails, but that's doubling the area in one tail.
mhm,
So I would find the area left of negative 1.13 and
mhm.
then just double that.
Okay. So I'll do the normal distribution table to the left,
Yes, of negative 1.13 and then double it.
which is just 2.26, negative 2.26.
No, it's yeah, you're using, I'm not sure what you're using, but the area is always between 0 and 1. Let me know if you want me to look at your screen.
Yeah, here, I'll share my screen. Mhm.
Right, so you want to go left of minus 1.13. That like that's the issue. Okay. That looks fine. Oh yeah, that's correct. And you got to just double that number.
The probability.
Yes.
which is just so 0.2584.
Right, 2585.
85. Oh, to keep rounding it, that's my bad. Okay.
So stay on your screen because to do the part B, the critical values, we can
Yeah.
do that together. It's your alpha level is 0.05. So you cut that in half. So put in your probability 0.025.
Here.
Yes. And then we'll calculate the z-score with that. So see how it's negative 1.96?
Hmm.
That's the left, or that's the test statistic, the top one.
Hmm. And then
And
we'll
then
do
the bottom one is
positive.
the positive of it.
Positive,
Good.
yeah. Okay,
All right,
follow.
good.
Yeah, I didn't take this, so I was
Oh, you
confused.
have to use the exclamation point thing that they say. So yeah,
Enter. Oh, enter.
that looks right.
Or I did that and it didn't take both. Or I do, yeah, exclamation equal.
Uh, yeah, try that.
Yeah, I'll just. Mm,
Okay, so I think what I'm missing here is that within means less than
mhm,
16 days.
mhm.
So I think that is the issue here, and that changes all the stuff. I guess, I don't know why this, okay. So the the issue here is that
Mhm,
the null and alternative are both wrong, so
mhm.
I do
Yeah,
apologize.
it's okay.
Um, the test statistic is correct, which is a good thing. So the alternative is mu greater than 16, and the null is less than or equal to
Mhm.
16. So you want to change
Ooh.
those.
I've just
The H0, yeah, to less than or equal to 16 for the top one.
mhm, this one.
Yes. And then greater than 16 on the bottom. So to me, within means that like that's what they think it is. The claim is that it could be greater than that. Now there's the first test statistic is it's one-tailed, so enter none in there. And this time, when you go to the distribution on the right, you want 0.05 in the right tail. So it's actually going to be a different value.
So I'll
Yes,
go
change
back
it to
here.
right.
Mhm.
Yeah, put probably a 0.05 in the yeah,
For
that
probability.
probability, yeah. And that should be 1.645 or 1 point, I
It
think
should
it's
be
6.4.
6.4. Yeah.
Yeah, 0.64. Okay. Now the p-value
Mhm.
is the right tail of 2 point or 1.13. So the z-score of 1.13,
Yeah.
and that's 0 point.
129.
Yeah, that's your p-value.
Mhm.
All right. Now, in both cases,
Mhm.
you do not reject, there is insufficient,
Mhm.
and those are always consistent with each other.
Mhm. Yeah. I gotcha. There we go.
All right, let's go look at the next one here. I'll share my screen. Hopefully,
So when
this
it's
one's.
within a time frame, it will always be
I guess I took it
uh,
to mean like they thought it was basically was always 16 days, and they were taking it to mean that it was up to 16 days. I
okay.
mean, I'm not a master of the English language, but
Yeah.
so stuff happens.
Yeah.
Nicely in the next problem here, they have given you the null and alternatives. You don't have to figure
Yeah.
those out.
Hmm.
They do give you sigma again. So
Hmm.
you're calculating a z. Your z is x bar minus mu over sigma divided by the square root of n.
Hmm. Which is
77.1 minus 80
mhm.
over 15 divided by the square root of um, 100.
Okay, I'll calculate that. Which is negative 1.93.
So you're gonna go to that Z table again, do the left tail of minus 1.93.
Mhm. Negative 1.93, and then that's 0.0268.
Good. And then your alpha this time, they give you a weird alpha,
Mhm,
which is okay, but your p-value is less than that,
mhm,
so you do reject. There is sufficient.
mhm,
And actually, it's always the same answer in both of
mhm,
these.
mhm.
It's never
Would be
inconsistent.
different. Got it.
Now, since it's a left-tailed test, there's no right-tailed value,
Mhm.
but you then have to go back and look and you want to put in 0.063 into the probability,
To the left, yeah.
and then you'll get some sort of a z value, which I've got here, minus 1.53.
53.
Yeah.
Gotcha. Yeah, all of that looks good. Okay, yeah, these aren't too bad.
Yeah, let's keep going here. The next one you sent over, maybe this one's a T, we'll see.
And this might be a T, yeah.
Okay. So this time we gotta read the words and figure out the null and alternative.
Right.
The average daily internet use at home is 2 hours and 20 minutes. Sample 49 homes showed an average usage of 1 hour and 45 minutes. We are interested in whether or not the average of that city is significantly different. So the
Mhm.
word different means not equal
Equal
to.
to, not equal to.
So um so typically it's 2 hours and 20 minutes. That's 140.
Okay, gotcha.
And you got to do that mu exclamation point
Which is
equals
point,
140.
yeah, yeah,
We'll see if that's right before we proceed.
yeah. I will do that. Okay. Yeah, that's correct.
Okay. So this time, like you said, T isn't really that much difference. It's X bar minus
Mhm,
U mu, but it's S instead of sigma.
mhm,
And so they say it's 1 hour and 45 minutes.
mhm.
So that's 105 minus 140
Mhm.
over 70 divided by the square root of 49.
49, yeah. Plug that in. Uh, it's negative 3.5. Yep, okay.
Right, now for C is a little bit different here. You need the degrees of freedom for a T distribution. Degrees of
Mhm.
freedom is typically n minus 1, which
Which
is
is
49
48.
minus 1,
Mhm.
48.
Yeah.
And then because it's two-tailed, you cut that in half. So
Mhm.
you want 0.025 in each tail with
Oh,
degrees of freedom,
So I'll
48.
go, mhm. So I'll do the oh wait, I'll go to the T table and then do
Yeah,
the middle. So I put
she
48
does.
and then our wait, the degrees of freedom is 48 and then our
Yes.
T value is
You're looking for the alpha. You're
oh,
looking for the T value.
two
Use the
tailed.
alpha. Yeah, you're either using the alpha to get the T or the T to get the P value, which is really alpha.
Wait, so what would I plug in here then? Because I'm looking at
The probability needs to be that's the one you got to fill in
fill in
point
for,
0.025.
which will give me the T.
Yeah, now why are we so different on that? Oh, because they're don't do sorry, don't do so there it's 0.25. So put
Mhm.
in 0.05 in the so the way that your calculator works, your 0.05 is in, yeah, put 0.05 in there.
Okay.
Yeah, now it's correct. What's they're
Mhm.
saying is the total in both tails is 0.05 when you use the two-tailed.
Uh-huh. So
I
that's
find that a little confusing, but that's the right
mhm.
p-value. If you did left-tailed, it would be 0.025 is the
Okay.
probability.
Okay, gotcha. Okay, so I'll go back.
All right, so the two values minus 2.02, 2.02,
Mhm.
and then your test statistic is way over here in the reject region.
Mhm.
And it's reject. We can conclude,
That the
can con-
average.
I'm just looking at what the difference is. Yeah, we can
So
conclude
we can't
reject. We can,
conclude. Yeah.
yeah.
It said the test statistic is wrong. The negative 0.02 and
2 hours.
then
Yeah, so 105 minus 140. So, oh, so, 49 homes, 2 hours and 20 minutes. So 140, 1 hour and 45 minutes. Is that 105? Seems like it.
1 hour and 45 minutes. That's an hour and yeah.
Could you share your screen?
Yeah.
Oh, okay. So those are the issue. Sorry, those are the wrong ones. I was looking at something else. Let me double check those one more time. It says two decimal places. Two decimal places, right?
Yeah, 2 decimal places.
It's probably a rounding issue. Um, oh, I used the wrong degrees of freedom. 48. It's 2.01, not 2.02.
Yeah.
That's the only issue.
Oh, I got it.
I mean, you can check if you'd like.
Yeah, because I would use the two-tailed and then
And then 48, and then probability of 0.05. You'll see that that rounds to 2.01, not 2.02. Really picky, really picky.
yeah, it's really technical. Yeah, there we go.
Okay, that is the last problem you sent
Mhm.
over, so I need to grab some
I
more
guess I'll
if
just
you
do
would
like
like.
the last one. The other ones are pretty like I think I got them.
All right, why don't you try this one here on your own,
Yeah.
and I'll do the calculations.
Mhm.
It's maybe a good chance to see if you have any questions.
Mhm. Let's see. 81. So the sample. Um, the sample 81 the average balance. Mm,
Let me know if you have any questions as you're
yeah,
working
I'm having
through it.
a hard time identifying how to set up like the null and then
So
the
there's a word in part A where it says formulate the hypothesis in dollars that can be used to determine, and then keep going. There's a word in there that tells you what it is.
whether the mean different.
Yes, that's
uh,
a two-tailed not equal to test.
So it would be
No, it's not the sample average. It's the one that's sort of accepted in the population.
so 81. Wait.
So sorry. No, yeah, this one there actually it is 1160 is
Mhm.
it's in an
So,
odd place. Yeah.
mhm.
So go ahead and
So
check that because it's easy to if we get that wrong, everything else is wrong.
yeah.
No comma in the well, it might be okay. I don't know if the commas make a difference.
Actually, I don't think it. Yeah. Yeah. So we have
Okay.
this,
So now calculate your t statistic.
mhm, which is should be 1,000. 1060 divided by, or sorry, minus 1200 over.
It's actually the other way. The
Mhm.
X bar, which is the sample, comes first. So 1200 minus
1200.
1160. Let me know what you come up with on that.
2.79.
Good. Oh, 3 decimal places.
Oh,
791 this time.
one. Yep.
Yeah. Now the p-value, I can talk you through that. You do need to know the degrees of freedom. Degree of
Which
freedom is
is 80.
80. Yeah.
Technology.
So this one's gonna be a two-tailed. Yeah, you got it. And then E. You do want to put your p-value in this
Mhm.
time. Your t-value, 2.791.
And here I get the probability. So
That's it.
four decimal, four decimal places. Let's take that.
And that's gonna round up to 0.0066.
And
And
then
then it is less than the alpha, so you're gonna reject H0. There is sufficient.
evidence. Mean the balance is got it. Okay, got it. How much time do we have left?
10 or 15 minutes or as
Okay.
much, as that as you need.
Yeah, I would have to
Um,
look at. I feel like some of these I could figure out because you're just like using the table.
yeah, I mean, I can watch you do them, or you can ask me questions. They're all from that table. Like I would split screen, have that
Yeah,
table pulled up.
yeah. So say like I'll just close some of these. Let's pull this here. So say like in a one-tailed hypothesis, lower tail, the test statistic is z equals 2.4. Find the p-value for this test. So lower tail means left.
That's right. You're using Z this time. Yep, there you
Yeah,
go.
so normal and then left. And then z is 2.4.
There's your area.
Answer, which is this last one. And then it says here in a two-tailed hypothesis test, this is find the p-value for this test. So this is two-tailed. So I'd use a two-tailed and normal distribution.
It's so this one's a little bit odd. There's two ways to do it. It's right. They're giving you there's two Z-scores.
Mhm.
You can either go, I guess we can make this work, but I always kind of use the right or the left and then double
Mhm.
it.
Okay,
So like the right of 2.6, and then you double that number.
which is
Um,
this.
yeah, so that's it being 0.009293.
Mhm. Yeah, 9.2, but this in this case it'd be 9.3, I believe. Yeah.
Yeah.
So this one. So why wouldn't like a
Let's
two-tailed
try it. So
table
we can
work?
use it, but then
Yeah,
you got to put in 2.6 and minus 2.6.
like this.
Well, it's already, yeah, you can see it's already
Yeah,
in there. And you
right
can see there it
here.
gives you the right.
Oh, okay.
It's just a little odd from
Mhm.
because I've seen so many of these, it doesn't lend itself to the easiest way of doing
Yeah.
it. But okay. So this is 0.0694 in the right tail.
Mhm. Like so. And then it's 1.48.
Got it.
Yeah. So this one, read the Z. Let's see. Yep. Read the Z statistic from the normal distribution table and just for one tail test a lower tail. So this is left once again.
Yeah.
We'll type that in, which is just negative 1.37. Yeah, these are pretty easy for the two-tailed normal the two-tailed test. So we can do two-tailed. probability of 0.0872. And then for the two-tailed, so it's looking at this one.
Yep.
Yep. Yeah, if a null hypothesis, yeah, I guess this is more the word problems. If a null
Okay, we look
hypothesis
at,
is rejected at 0.
this is a common test question you'll see.
Mhm.
So if the next alpha is greater, then it's always rejected.
Okay.
If the next alpha is lower, it's sometimes is rejected. This isn't always because
Always.
point two is bigger than the point one.
Right one, yeah.
And the one above it is kind of this is the one I just mentioned, which is that sometimes, yeah,
Will be.
may be rejected or not. I don't know why that seemed to
Wonder if
so I mean you can check that one, but it's gonna be the same wording. I guess I don't know why. I mean to me the language it's the may I guess it's the language, the maybe,
yeah.
or
Yeah.
is it we oh I'm sorry, not rejected. Sorry, I didn't read the word carefully. If it's not reject the 5% level of significance, it's not rejected at the 1%. No, is this the same one? Oh no, is not. Sorry, this I'm looking at the screen.
Yeah,
Will
here,
also not be. Yeah, well,
yeah,
it's the one
also.
above it.
But yeah, will also not be
Yeah.
this one. Yeah. And then in order to test the following, I was said the null hypothesis will be rejected if
So because it's a right tail test, you're looking for a greater than.
mhm,
So the in the alternative, the greater than. So see how letter A is Z greater than or equal to Z alpha.
here.
Greater than's the, I don't know, the pointy end to the right. One,
Mhm,
the first one. The one you keep pointing to is less than.
this one.
That one's great. That one's greater than. Yeah.
Yeah. Because this is right. This is the
Yes. It has to
null.
match the alternative,
Uh-huh.
which is great, which is the second one, the greater
One.
than. Yes.
Yeah. Got it. And then this one is when the following hypotheses are being labeled. So the significance of the null hypothesis will be rejected if
So
null
it's
is always
always
the bottom one, right?
null is the top.
Top,
Null
the
is the
top one.
initial.
Yeah.
Yeah.
So the
And it's
null
always if the p-value is less than alpha. That's like a standard definition you have to know. P-value less than alpha.
the first one.
Yes.
There you go. So loud.
Yeah, exactly.
And then yeah, same
If
with
null is rejected at 2, it will may be rejected or not rejected.
yeah, because
Yeah,
it's rejected. So super simple. Yeah, these are like a little different, but the manager of a laptop company dealership is considering a new bonus plan to increase sales. So
there you go.
then,
That's the keyword.
yeah, so increase, which means we're looking at wait, sales are 9 laptops per week, which the following is for the testing. So we're looking if it's going to be greater than
For the claim. The
claim.
claim has to be is the second one. Now it has to be, it's never an equal to.
Mhm,
That's why A is wrong. But part B there is just a mu greater than 9
mhm.
in the HA. Up one, up one.
This one because
Yeah. Yeah, the claim is the second one. That's
one,
the alternative.
of one, because it's never going
Yes.
to be this one
It
or
can't be an equal to in the
equal to,
alternative.
so equal to, this is the wrong way, and then this has to
Yes.
be greater. Yeah, got it. And then a machine is designed to fill toothpaste tubes on average with 5.9 ounces of toothpaste. The manufacturer does not want any underfilling or overfilling, which is the correct hypothesis. So there's not like an increase or, well,
That's right.
no
It's
underfilling or overfilling.
they
So
just want to know if it's different.
different, yeah. So it wouldn't be. So are we looking to if it's gonna be like equal because they want it at an
The
equal
null
level?
the null has to always be an equal.
Equal.
It's
That's that one.
that one's flipped. basically,
Right,
to
right.
what the correct one should
Yeah.
be.
So this is it.
Yes.
Yeah. Yeah, and then the average manufacturer work in a particular city was 40.9 hours last year. It is believed that the recession has led to a reduction, so decrease to test the validity of this belief, which is the correct hypotheses. So we're looking at not the alternative, the H, the first one, like
It's reduction.
the
Reduction means less than.
less than. So
Yeah,
it's either,
that's the less than. Yeah, that one
yeah,
you're pointing at right now.
yeah, the alternative. Yeah. Okay, yeah, that's literally everything I wanted to work on.
Nice. All
Yeah.
right, good
Thank you
job.
so much.
Let's go ahead and stop here for today. We just say goodbye